All right, everybody. So it looks like we're going to start part 6 of this series. First thing I'm going to do is put... Where are my glasses? Oh my gosh, I think I left my glasses at work. Well, I can use the magnifying glass. I want to beep out, just kind of go around beeping around stuff that might look suspect. Just make sure everything's good to go. I believe everything is. I kind of once over the board here, and I didn't see anything that looked broke. Everything looked okay. So we're going to work on repopulating this baby. Yeah, so that'll be fun. That'll be awesome. I have a little list. Oh, shoot. I had a little list I will have to find of, you know, what's what parts. It's around here somewhere. I'll find it. Yeah. So I'll do that. I'll find my list of parts that I removed. Nice and smooth. This board came out really good. Clean. Now it is officially really corrosion free. So let's go ahead and find the list of parts and start gathering parts. Okie dokie. Got our parts list. Got a collection of parts along with all the chips. Okay. I think I need to change the tip. I do. And let's go with this guy. Turn it on. Okay. And, well, let's do the caps first. Ouch. You know, I so need my glasses. Is this going to be right in your way? Yeah, kind of. Not terrible, I guess. Right? Yeah, that's not terribly in your way, is it? No, you can still see what's going on, I think. I do have to kind of pull it out of the way. Just solder it top side. Solder's flowing pretty good on there. Nice. And our first chip, our first part is in. This would be actually kind of cool if I ever got set up to do it. I'm not that savvy about this kind of stuff, but this kind of stuff right here would be kind of cool to do a live stream. You know, just sit here and do this and check and see if people are chatting and stuff. I need to get into that and figure that stuff out. I don't, guys, I don't know about doing that stuff. I'm not good with that kind of stuff. But I'd like to. I think that would be cool. I like interacting with you guys. I think it's really cool. That way you can ask me something if you see something. Maybe I can answer. I don't know. Did everybody have a good, what is today? Tuesday? Everyone have a good Tuesday today? I did, not too bad. This is really good. The solder's flowing really good. You sand down that junk, you know, and get that nastiness off of there. The solder's good. Good connections everywhere, good parts. Nobody wants boards that are all corroded out, you know. They drop right in nice. Fold those leads over really good. Darn it. Darn it all. You know what I'll do? I'll try keeping this thing up out of the way and put some Coke bottle glasses on. These, I call them my Coke bottle glasses because they're like 3 times magnification. 3.5 or something like that, crazy. So I can put those on and get right down in here. But I have to be right down on it, otherwise it hurts my eyes. These are 0.1 microfarad. You look on the original caps here, it says 104, and the 4 in that is the multiplier. So you have 1 0 and 4 zeros. So 1 0, and then it's like 100,000 picofarad is 0.1 microfarad. That's how you read those things. And you just kind of, after a while, the codes are always in picofarads, unless, not always. Sometimes it'll be stamped UF, you know, like it'll say 47 UF or something like that. Electrolytics. These little guys right here, these little codes are always in picofarad. Like 104, that's 1 0 and 4. That's 100,000 picofarads. Yeah. Then you see something like 473. That'll be 4 7 and 3 zeros, which is 47,000 picofarads. Which will usually be abbreviated down to like point, maybe, I don't know, 0.0047 microfarads or something like that. Something like that. Capacitors. There's one. It's like 12 of these guys. Decoupling capacitors. Okay, looks like we got one more. And I see I need one right here. Decouplers. That's a resistor capacitor. Emitter base collector. Let's do this guy. NPN transistor. There's a diode right here. A rectifier. Okay. Resistor, cap. Resistor, resistors. Resistor cap. And all these chips. This one looks like shit right here. That one looks like garbage up in the corner. It'll be okay. You know. Okay. Alrighty. I'm going to take a little bit of a minute. I'll be back. I'm actually going to do some more of it off camera, like all these resistors and stuff. I'm going to go ahead and take care of all the resistors and stuff off camera. Okay, and our board is put back together. Make sure everything's in the right orientation. And all of these are good. These two guys up here are looking good. Okay. This chip right here I did not have, so I'm using the old one that I removed. I hope it's good. I did order some. I ordered 20 of these. So it's a 4078. It's a 8 input NOR gate, which is something, it's an oddball thing. I don't have any. Yep, but this bipolar ROM is, yep, notches in the right spot. So it's looking good. It's all repopulated. Look at the back side. It's all looking really good. I ran a little jumper from there. Just a little jumper. So I'm ready to put this thing back in the cage and fire this thing up, and hopefully our woes are taken care of, right? I got all these resistors here looking really super good. Yeah. All right, let's do it. Let's put this thing back together. Alright, and we're looking good. Board's back in. I ran audio 2. As I spoke with Matthew Janicek. I'm not sure how to pronounce your name, sir. Sorry. And I was informed that audio 2 is the second custom chip on the game PCB, so I should check that too. So I have wired audio 2 into here so I can test both audio 1 and 2 now. And right now I am on audio 2. I've been testing audio 1 right there. This is audio 2. So, and we are running. And not only are we running, I've played a game and it actually is working. I don't know if I elaborated on why I did this in the first place. Number one, I wanted to do it. It was bothering me because it was corroded. Number two, this thing was kicking back a NVRAM error. It was saying that this chip was bad, and I knew this chip wasn't bad. So it just wasn't getting to this guy. And there's circuitry over here that enabled this RAM. That's what prompted me to say, okay, I need to go ahead and clean this up. So that's the main reason why I did that, but I wanted to do it anyway because it was corroded. There was corrosion there, and now there's not. So, and now it's got new parts. Man, this board right here is redone. It needed to be, though. It was trash. It was absolute trash. But I'm going to go ahead, we'll fire this thing up. I'm going to set the camera up and we'll play some Robby Roto. And then I'm going to let this thing run for a couple of hours and then call it good. So let's set up and play some Robby Roto. Okay, we're all set up. Got the lights out a bit. And you'll remember when this thing would mess up, it was right at the beginning. It wouldn't even start the maze. It would reset. Remember how it would try to set the maze like 3 times and then the game would reset. So now let's check it out. And this is the second audio channel. So we are testing the audio out of the second, I don't know what they call it, the Astrocade chip. I'm not sure. I think that's what they call it though. It's basically kind of like Midway's version of the Pokey chip because it does input-output, it does controls, and it does sound. So it's kind of Midway's Pokey, if you will. Anyway, let's go ahead and start this thing up. Yep. This is audio 2. There's obviously not as much going on. That reminds me of Zookeeper. Oh boy. Oh boy. Those sounds really remind me of Zookeeper. I like this game. I could see playing this for hours. See, this accompanied with the other chip make all the sounds. The other one makes the walking sound and that kind of nonsense, you know. It's really, really loud. Oh, that thing killed me. See, I didn't know if that thing could kill me. All right, let's switch over to audio 1 again. Okay, and let's coin the thing up. This is the loud audio channel. Oh! Oh, come on. Darn it! This is hard. Well, it's hard when you can't see. You need color for this game. It's pretty cool. I like this game, though. But yeah, I believe we got it, guys. I really do. I do. Got a nice, clean, zero corroded board now. I like it. All right. All right, I'm going to hang out here with this thing and leave it on for a while, and we'll come back. I'll come back to you in a couple hours. Hopefully my my score's still there. Let me put in. Oh, I didn't put anything in. I was on the board though. I want to wait and see if my score's still there. It was like 16th or something like that. That's a good way to tell you if these things reset or not. Is put a score on there and then you just make sure your score is still there. You don't have to sit here and watch it constantly. That's what happened last time I had this thing going. Yeah, see my scores? 16 and 18. My two scores. Yeah, see? Alright. I'll see you in a couple hours, guys. Well, as you can see, this thing has died on me and it's in a stuck reset. And I'm not exactly sure what's wrong with it. I'm not 100% positive that it's this guy. But it could be my decoders. Remember, I did not replace those guys. Could be this bipolar ROM chip. I was suspecting this guy, but it's fine. I'll turn this off and go back to Logic Analyzer and just kind of repetitive run it. And it's a NOR gate. It's an 8-input NOR gate. And basically, the only time a NOR gate is going to be a 1 is when all of the inputs are 0. Any other combination, you throw a 1 in here, it'll be 0. So that makes it easy. The NOR gate only goes high when all inputs are 0. So I'm just triggering on 0. And you'll see every time I get a 0, I get a pulse. So that thing is working just fine. I'm going to move on and suspect these guys because test does nothing. This thing is dead. So I'm going to suspect these 139 chips, first of all, because test does nothing. So, and I've already probed all of these guys and everything looked fine here, all these buffers. So next thing I'm going to suspect is these guys right here, these 139 chips. Okay, as you can see, the fluke has come back out. I did go ahead and I replaced those two 139 decoders on the ROM board as a shot in the dark, and it did not make a difference. But hey, I got two new chips on the board. So I'm going through the fluke, and all I can do is this guy, this guy, this guy, and this guy. When I get to these upper address bits, they're all bad. All these are bad. These ones are good, and then they're bad from there on out. So going into the upper address range does not work. But I can do a ROM at 0 to this, and it's 9286, 9286. That'll be good for sure. But all of the ROMs in the upper address don't do it. That one's good. Now we'll go to A000 to AFFF 1002. We'll go to A to AFFF 1002, go. And this will fail. Okay, and not only, check this out, go more, 7A06. Let's do it again. Repeat. 7A06. It'll give me a completely different number this time. That's just random nonsense. random whateverness. Yeah, see? ED6E. So this is just not decoding correctly. It's not a data error, so to speak. I think it's just a complete failure to address, decode. So I'm going to have to look at the schematic again and look at these upper address ranges and see what's going on. How come the lower address, the lower 4 address chips are okay, and then the rest of them are not? So that's what we got to look at. Alright, back to the schematic. You guys are the best. I mean, I swear. And you know, I should have caught this. I should have seen this. Sentinel Deluxe. Cut trace between that is 8 and 9. That's pin 8 and 9. Right there. That is pin 7 going between pin 8 and 9. And that is the second chip down. Right at the point of this. You know, right at the point here. So that's pin 7 going between 8 and 9. So if we come over here, and you know what I'm going to have to do is grab this guy, because I can't do this one-handed, and put this on there, right? And I need this guy because it's got the clamp, you know, the clips. Just kind of, come on. It's tough to do one-handed, guys. And let's put this on beep. And select. There we go. Audio beep. Let's put this to pin 7. Right like that. And let's take this, and it's this trace right down here between 8 and 9. And if we see that, that is supposed to be going right here between. There's no continuity there. That, you know. So I am definitely going to fix that trace, and then hopefully that'll make it to where this thing will read the ROMs. You know, go through the ROMs and stuff like that. So I think that's what I'll do. Let's fix that trace, pop this thing back in there, put the fluke back on it, and see if we have all of our ROM ranges. Because if you remember, last time I was testing, I could test, these guys were okay, but the upper address chips I couldn't read. So I don't know, let's check that out. Alright, let's repair that trace and come right back. Okay, and here is the fix. That pin connects right here. So I got a little wrap wire going around, making its way to there. And I will flip this guy over. Yeah, it's right there. Come on. Nicely tucked in. And it is not shorted to this, I've already checked. So yeah. So now let's see if we can read those ROMs. You know what let's find that on the schematic and find out what that is. Let's find out what that little trace what that did. What circuit that it's involved in. Let's do that. Okay, we are hooked back up after repairing that trace. Hooked back up with the fluke. And if I go right into ROMs, let's do A000 to AFFF, and that is 1002. And let's try it again, repeat. And I'm sorry, I did not go to the schematic and find out what that pin did, but we will do that. I just jumped right into testing this, and it fails. And we're going to get 79D4. 79D4. Let's try it again. I wonder if this address range is just not accessible by the fluke. I don't know. Because 0 through 3FF is fine. And it came up with something different this time. 039F. It's just getting... It's like nothing's being accessed properly in that upper range. So let's stop this. I want to look at what that was. That trace that we fixed. I want to look at that, what that was. And I also want to see what is the difference between the lower 4 ROMs being turned on and the upper 6 ROMs. What's different between those guys? Why can I do the bottom ones but not the top? You know, that's kind of what's throwing me right now. So let's just look at the schematic and kind of try to figure out what's going on. Plus I'm curious to see what that gate was that that trace was broke. And that trace was broke when I first put this thing together, and it was working. So what was that all about? But you know what? When I did put it into a test, I was getting a failure about something with RAMs. It was giving me RAM 5 and 6, or test 2 was giving me 5 and 6, which I looked it up, and it was some RAM thing, I think. I'm not exactly sure. But it was still running. It was a memory protect or something like that. That's what it was. Memory protect. But so that would probably fix that. But this is a different problem. The memory protect failure in the test that I saw before, which I don't think I filmed, is probably what that broken trace fixed. But this is something totally different, and I'm hoping it's not that programmable logic chip, the decoder. It's a decoder. You know, that's not a bipolar ROM. That is a PLD, programmable logic device. And if that's bad, we're screwed. You know, and I know that is what selects the ROMs. That's what enables the selectors is that thing. So let's take a look at the schematic and just kind of look it over. Okay, this solves the mystery of why I was getting that error 5 and 6, which was the memory protect failure. This is that gate right there. Pin 6 was the output, and that's the trace that was broke. This trace going up was broke. It goes up to U4 on pin 8. And then that, in turn, goes into this guy. And that output, in turn, goes into this guy. That output goes all the way up here. And and enables the RAM. That's the NV RAM right there. It's the chip select, or the output enable for the the whatchamacallit here, NV RAM. So now to look at our decoding. Let me see if I can do this like this. Just kind of maneuver this thing. Let's go up. And X, 9, and 10. Those are two ROMs that we cannot access. This guy right here is that little jumper thing, X32. That's fine. Address 11, is it? Yeah, that's address 11. Goes through, and address 11 is pin 18. So that's fine. These are our problem right here, these chip selects. They come down, and they come down, and they go over, and they go over to the selector. Okay? I know these selectors are good. These 139s, are nothing wrong with them. They get enabled by this guy. Field Programmable Logic Array. That guy gets a bunch of control signals, which I'm sure those control signals are there. This thing also enables the 139s that fire the other ROMs. If you come up here, the first 4 ROMs, 1, 2, 3, and 4, are also fired by 1, 2, 3, and 4 are activated by U8, the low side of U8 right here. Okay, and that gets activated by pin 17 of this guy. So pin 17 is fine. It's doing its thing. Now this line is pin 16. That is supposed to activate this guy, which turns on X 5, 6, 7, and 8, which is not happening. Okay. And then pin 14 and 15 come over and activate these guys. Yeah. That's pin 14 and 15. Where's this guy go? He also goes up way up. I lost him. I think he's activating this guy, maybe? I don't know. He is right there. Oh! Darn it, I keep losing it. I think it activates. Okay, all the way to the left. It goes over here. It goes through there, which is strange. I don't know. I need to look at this off of the cameras. I can't hardly do this. But it's looking like it might be that field programmable logic array may have died. And if that is the case, I don't know what to do, guys. Because it was running fine. It had that error. And that's what that trace, I guarantee you, that trace that was broke, that fixed that error. This thing was chugging along and running fine, and all of a sudden now it's completely dead. Won't do a thing. So I believe that that field programmable logic array died. And I don't know what to do about that. So I don't know what else it could be. I think what I'll do is I'll just probe around on the board a little bit and make sure that everything, the signals are all good. And if the signals are all good and I can't find anything blaringly wrong, then I'm just going to say it's that field programmable logical array. I'll make sure that those are not being accessed. You know what would be really great is if I had an extender card to plug in the memory board while I have the fluke plugged into the CPU board so that I can probe those 139s and see if they are actually being enabled and stuff while I'm hammering addressing and stuff like that. But I can't do that because of this cage. So I'm going to regroup, do some thinking, and I'll be back. But my initial diagnosis right now is I think that chip, that logic array chip is dead, I think. Okay guys, I'm sitting here looking at this chip, this FPLA, and all of these inputs do what they should. All the inputs are toggling good. It's the outputs, I don't know, because right now I can't tell if this is supposed to be firing any of the upper address ROMs. I really don't know. Yeah, I don't know if most of the program hangs out down in the lower address. Probably. You know, I bet you that 0 to 4000, 0 to 3FF is probably the bulk of the program ROM. And the other ROM is like game ROM or probably graphics ROM or that kind of stuff, I would imagine. But it looks like it's all accessible. I can't remember if I tested all of them ROMs with my fluke. I'm going to have to go back through my video and see if I did those upper address, if I was able to read those upper address guys with the fluke. I'm going to have to check that out, as I don't remember. Yeah, so I don't know. This is a stumper so far, but I do have an extender coming. I bought an extender, a card extender, so I will be able to put the probably the CPU board out because it's lighter, and hook the fluke up to it and probe that ROM board, you know, that memory board, and see if that that logic array chip, see if it is actually, see what I'm going to do is I'm going to use the fluke and I'm going to try to read those upper address ROMs, and it should turn on those 139s that decode that signal to turn those on. And if it doesn't, then I know that that chip's bad. It's really that simple. And then there's, you got to try to come up with some kind of a solution. Right now, I am really suspecting that that chip is bad, but I won't know for sure until I get that extender, so that I can do two things at the same time. I can probe that chip while I use the fluke to hammer those upper address ROMs. So that's the plan, Stan. So that's going to do it for this this section of this video. I've got to wrap it up because I can't do anything until I get that extender in the mail. And when I do, we'll be back for another part and more testing. Yeah, just a little thinking out loud here, guys. We have 4 ROMs that I can read. No problem. Every time, 4 of them. The first 4. X1, X2, X3, and X4. There is nothing special separating X4, X5, X6, X7, X8, 9, and 10 from 1, 2, 3, and 4. They share the same address bus. They share the same data bus. They have different decoders turning them on, but those decoders share the same chip. Let me rephrase. They share the same source for activation. That U10, that field programmable logic chip. 139s, there's 4 139s. There's actually 2 chips, but there's 4 selectors in those 2 chips. Only one of the 4 selectors is being successfully turned on from U10. The other 3 are not. That's the only difference. So what I'm suspecting is happening, and this is what I'm going to find out when I get my when I get that extender card. I'm expecting to see no ROM being, those ROMs are not being fired, is what I'm expecting to see. The chip select is not going low. So what that tells me is whatever is lingering on that bus, because everything is staying tri-stated. This is a weird system. I just got to looking at this, and the data bus and the address bus are shared. So this depends on everything to tri-state. Whatever's not being selected is tri-stated, so that one device dumps to the bus and is read. Or one device is turned turned on to be able to be written to, such as the RAM, so that whatever's on the bus writes into whatever's chip is selected. So what I'm suspecting is happening is when my fluke is trying to read from these ROMs in the upper range, and this is why it's getting back erroneous data every time. It's because everything is tri-stated. And the fluke is interpreting whatever it finds on that bus. Okay? Whatever is lingering on that bus, whatever floating nonsense, whatever it finds. There's nothing concrete. There's no solid signals. That's why it's getting goofy stuff back in every time. So I do believe, even stronger now, that logic array chip is no good. Which is really unfortunate. But I'm going to verify that for sure, for certain, when I get that extender, because I'll be able to just zoom right in on it, try to access those ROMs, and see if that chip, see if the output on that U10 goes low. That's supposed to activate that selector. That's how you tell that. So that'll be next. This one's on hold for a little bit until probably after the holiday. You know, after the Christmas season, probably, because I did buy extenders, and I bought a RAM extender as well. So no guesswork. I'm going to be able to extend those RAM cards out and actually probe the outputs. And 9 times out of 10 on these 4027s and 4116s, when they're bad, the output is completely dead. It either floats or it's always stuck or something. So this is a long series, but it's, hey, it is what it is. Sometimes these things just one thing after another. But we will get it. We'll get it. But the hard part, if we verify that that chip is bad, the hard part is going to be tracking one of those down, or how to go about getting one of those. If anyone knows anything about a lead on hobby ROMs, would hobby ROMs have that? I don't know. But anyway, guys, we'll see you on the next part. It's going to be a little bit because I got to wait for them extenders, and that way I can verify what I'm suspecting. And that's it for this one. Thanks a lot, guys, and there will be, part 7 eventually, but it's going to be a while. So take care. Merry Christmas, everyone. Happy holidays. Whatever season you celebrate, happy that. Look at this little baby cat, by the way. She just loves me. Always hanging out with me.